Hello friends and namaste. Today we will discuss how can we find the maxima, minima or extreme value for the function who have the variable more than one. Okay. So how can we do or how can we find the maxima and minima of the function which have more than one variable, which have the two variable, which have the three variables or more than three variables. So what are the basic method? What are the working rules and what is the basic procedure to find the maxima minima of the function which have more than one variable, two variable, three variable or more than three variable. So what is the basic procedure? I will here explain for the two variable and the three variable, and after that I will explain how can we find the maxima minima for more than three variable. So what is the basic procedure? Basic procedure is that we have to analyze the partial derivatives for the two variable, for the three variable or more than three variables. Okay, we have to find the corresponding partial derivatives, and we have some relation between that corresponding partial derivative, and if that relations are satisfied, then we can say at that point there is maxima, there is minima, there is neither maxima nor minima. So okay, let's suppose this is the function z which has the two variable x and y. Okay, so what will happen at certain points? Each there will be maxima, or is there will be minima, or is there will be the saddle point. Okay, what we have to do? Okay, we can clearly see that this is depending upon the two variable x and y. Step number one is that we have to first find the partial derivative with respect to x and with respect to y. So it will be del f upon del x and del f upon del y for function x comma y, which is depending upon the two variable. What is step number two? Step number two is that we have to solve that partial derivative. Okay, with respect to x we have to solve, with respect to y we have to solve, and when we solve that partial derivative equation simultaneously, then we will find some certain points. At that certain points we will analyze the maxima and minima. Let's suppose that certain point is a1 comma b1 and a2 comma b2. Let's suppose that certain point is a1 comma b1 and a2 comma b2. Step number 3 is that we have to find second partial derivative. Del square f upon del x square, which is second derivative. Del square f upon del x del y and del square f upon del y square. Okay, step number 3 is that we have to find second partial derivative, and we have to suppose with respect to x second partial derivative as r, and with respect to x and y, which means first you have to do differentiation with respect to y, then you have to do with respect to x, which is called del x del y, and we have to let as s, and with respect to y second partial derivative we have to let as a t. So we will get r, s and t, and we have to find the value at r, s and t at corresponding points a1, b1 and a2, b2 and so on. Okay, which I have get from the first partial derivative corresponding to given variable. And given variable are x and y. When I will solve the first partial derivative, then I will get certain points, and I will satisfy that certain points in second partial derivative, then I will get r, s and t. R means with respect to x second partial derivative, s means with respect to x and y second partial derivative, and t means with respect to y second partial derivative. Then we will find r, s and t. Okay. Okay, what is final step? Final step is that we have to find rt minus s square. What we have to find? Rt minus s square. If rt minus s square is positive, greater than 0, but there is also condition that r should be less than 0. If both conditions are satisfied, then there will be maxima at that point. There will be maxima at that point. If rt minus s square greater than 0 and r is less than 0, then there will be maxima. And for minima, if rt minus s square is greater than 0 and r is greater than 0, then there will be minima. So it is overall depending upon r. If r is less than 0, then there will be maxima, and if r is greater than 0, then there will be minima corresponding to rt minus s square is positive, greater than 0. And if rt minus s square is 0, or I can say rt minus s square is less than equal to 0, then there will be a saddle point. So there will be no condition of maxima and minima. There will be saddle point. If RT minus S square is less than equal to 0, then there will be saddle point. If R is less than 0 and R is greater than 0 for corresponding RT minus S square greater than 0, then there will be maxima and minima. So this is the basic working rule, basic procedure to find the maxima and minima for the two variable function. What we have to do, we have to find first partial derivative with respect to variable. We have to solve. We have to, when we will solve simultaneously, we will get some certain points, and at certain points we will satisfy in second partial derivative at R, S and T. Once we get R, S and T, then I will find RT minus S square and R. If this condition is satisfied corresponding, then we will say there is maxima, minima and saddle point. So this is for the two variable. But what we will do for the three variable?